You hold a grain of sand in your hand. It seems tiny and almost weightless, but if the eye could see into the depth of its matter, an entire world would unfold, a dance of atoms, invisible fields and emptiness that in fact makes up most of its volume. This simple grain of sand already raises the question, what governs the world? Numbers, waves of probability, or something beyond our understanding? For centuries, humans have sought the fundamental truth. Plato spoke of the world of ideas, where numbers and forms exist in pure and unchanging perfection, and our world only reflects them. Physicists of the 20th century encountered an unexpected discovery. Reality is not arranged as we are used to thinking. At the foundation of everything lies the quantum world, full of uncertainty and paradoxes. One of those who changed our perception of the universe was Richard Feynman, Nobel Prize laureate, a man whose lectures were listened to with bated breath. He said that quantum mechanics cannot truly be understood. It can only be believed in, like a kind of magic, which nevertheless describes nature with perfect precision. A particle can exist in different places at the same time. This is not a metaphor, but a strict experimental fact. Photons pass simultaneously through two slits and create an interference pattern, as if they were everywhere at once. Physicists still argue about how to explain this phenomenon. Some believe that a particle exists in many parallel worlds, others that we must abandon our familiar notion of reality. This paradox inspired philosophers, artists, and filmmakers. Recall the film The Matrix, where the hero discovers that his world is only an illusion, while the true reality is hidden behind a veil. One of the boldest researchers whose ideas are reshaping modern science is Carlo Rovelli, an Italian theoretical physicist, author of Loop Quantum Gravity. He claims that space and time are not fundamental entities, but rather consequences of interactions. In his book, The Order of Time, he writes that time may be an illusion, a convenient tool for describing processes, but not the true foundation of existence. Past and future exist only as shadows, while the present, in the usual sense, does not exist at all. These ideas sound almost mystical, but their roots lie in precise calculations and experiments. Quantum entanglement, discovered as far back as the 1930s, showed that particles can remain linked with each other at any distance. By measuring one, we instantly affect the other, even if they are separated by an entire galaxy. Albert Einstein called this spooky action at a distance. Yet today we use entanglement to build quantum computers and communication systems that will be immune to hacking. The human brain has also become a subject of such hypotheses. Some scientists suggest that it may use quantum effects to process information, opening a new hypothesis about the nature of subjective experience. Roger Penrose, a British mathematician and physicist, Nobel Prize laureate, as early as the 1990s, proposed that consciousness is connected to quantum processes within neuronal microtubules. His ideas are controversial, yet they continue to inspire neuroscientists and philosophers. When it comes to immortality, quantum physics once again throws paradoxes into play. The hypothesis of quantum immortality suggests that consciousness may continue to exist in one of the branches of parallel universes. In one world, a person dies, in another, they go on living, and experience is always tied to that living branch. It sounds like science fiction, but the idea is grounded in the mathematical rigor of Hugh Everett's many worlds interpretation. Such reflections push us toward a new perspective on our own lives. If reality is multi-layered, if time and space are not fundamental, then perhaps our thoughts and choices matter far more than they seem. And if you're curious to explore such questions with us, give this video a like so that we know these journeys into the depths of science resonate with you. And if you don't want to miss the next stories, be sure to subscribe to the channel. Science does not give final answers, but that is precisely its strength. It opens new horizons, makes us doubt, and compels us to search. And philosophy helps connect discoveries with the inner world. Every breath is part of the vast process of entropy, which drives the entire universe from order to chaos. And at the same time, it is thanks to entropy that we can perceive the flow of time and the very fact of existence. Scientists define entropy as a measure of disorder or chaos in a system. The higher the entropy, the more chaotically energy is distributed, and the less order there is. Put very simply, entropy shows how hard it is to return everything to its original state. For example, ice in a glass melts and turns into water. This is an increase in entropy. To gather the melted ice back into the same cube is nearly impossible without an input of energy. In terms of physics, entropy is linked to the number of ways particles can be arranged while maintaining the system's overall state. The more such ways exist, the higher the entropy. Let us explain entropy through simple images so it becomes clearer. Take the kitchen. Imagine you are preparing dinner. On the table, the ingredients are neatly laid out, knives and dishes are in place. This is low entropy, order. After cooking, the kitchen turns into chaos. Dishes in the sink, crumbs on the table, ingredients scattered. Order is broken, entropy has grown. To restore it, you must spend time and energy. The cosmos works the same way. Stars are born from gas clouds, forming orderly structures. Over billions of years, they die, explode, and turn into clouds of dust and atoms. Matter disperses, entropy grows. And yet, from this chaos, new stars and planets emerge. The flow of entropy creates the cycle of birth and destruction. These examples show that entropy is not just an abstract law, but a phenomenon that manifests everywhere, in our homes, in human life, and in the universe itself. When the gaze is lifted to the stars, the past opens up, the light that has traveled to us for millions of years. And perhaps the star whose light just reached us no longer exists. We look deep into time while simultaneously being aware of our present. Within this paradox lies the beauty of science and philosophy. They not only explain the world, but also teach us to see it anew. When we speak about the nature of the universe, it is as if we step into a grand theatre where tiny actors, particles, perform on stage. They obey laws that contradict common sense. We are used to thinking of the world as space filled with objects and time flowing linearly. But quantum physics shatters these familiar ideas. One of the most striking examples is photon entanglement experiments. In the 2000s, Alain Aspect, a French physicist, carried out a series of elegant experiments for which he ultimately received the Nobel Prize. He proved that the world is indeed non-local. When two photons are born together and fly apart, they remain one whole. Measuring one instantly determines the state of the other, regardless of the distance between them. This result overturns our understanding of causality. If two events can be linked instantly, even across light years, then space and time are not absolute. This shook the scientific community and became the foundation for a new physics, where Newton's familiar laws appear only as a special case of a deeper structure. We can approach this mystery through an image. Imagine the entire universe as a fabric woven from threads. Each particle is merely a knot in this fabric. When one knot trembles, the whole fabric vibrates. Entangled particles are like two notes of the same melody that can never be separated. These ideas inspire philosophers to new questions. Martin Heidegger, in his book Being and Time, wrote that humans exist not in space and time, but together with them. And today, physicists seem to confirm his thought. Time and space are born out of a deeper structure we do not yet fully understand. Modern cosmologists, such as Sean Carroll of Caltech, try to explain this through entropy. According to him, what we perceive as the flow of time may be a consequence of growing disorder in the universe. It all begins in a state of low entropy, and then the world gradually degrades into chaos. Yet it is precisely this degradation that makes memory, causality, and the very concept of life possible. Carroll writes that without entropy, we could not distinguish the past from the future. But this raises a question. If time is only a consequence of entropy, does that mean it does not exist at the foundation? And if time does not exist, then what are life and death? Stories from the lives of scientists often add humanity to these abstract ideas. When a young Albert Einstein worked at the patent office in Bern, he would spend hours pondering what the world would look like if he were racing alongside a beam of light. These reflections, far removed from strict experiments, led him to the special theory of relativity. Today, more than 100 years later, scientists are once again asking questions that sound like philosophical riddles and are seeking answers within quantum reality. There is another astonishing fact. Studies have shown that a particle can remain in a state of superposition, that is, in multiple states at once, until it is observed. This makes us wonder, perhaps our consciousness plays a more important role in the structure of the world than previously thought. Physicist John Wheeler said that we participate in creating the universe, like spectators whose very presence makes the play real. If we allow this thought, life itself takes on a new dimension. We are not just random observers. We are co-authors of reality. What we give our attention to happens and gains strength. Then the choices a person makes each day take on cosmic significance. Within this lies both inspiration and responsibility. I suggest a small exercise. Close your eyes for a minute and imagine that everything around you consists only of waves of probability, which collapse into reality only when you pay attention to them. This helps us feel that reality is not given once and for all, it is created in the moment. If these ideas seem exciting to you, support this video with a like. It will help bring stories about science and philosophy to more people and allow us to keep creating them. Some scientists go even further and speak of quantum immortality. This hypothesis seems both frightening and mesmerizing. In the many worlds interpretation, there always exists a branch where you survive. From your subjective point of view, death never arrives. Consciousness always wakes up in the world where you go on living. This thought sounds like the plot of a science fiction novel, yet it is built on real mathematical models. And the more we think about it, the more we realize that life is not only a physical process, but also a mystery that will never be fully unveiled. I want to ask you to share your opinion in the comments. Does the idea of possible quantum immortality comfort you, or does it frighten you? It is important for us to gather different perspectives because they help broaden our picture of the world. And when we look at all of this, it becomes clear that we are only standing at the very edge of understanding. Science gives us tools, philosophy gives us language, but beyond the horizon, there is always something that escapes us. It is precisely this elusive that fuels the desire to explore further. When we begin to speak about fields, the familiar language of physics moves closer to philosophy. Fields are not objects, but rather the underlying fabric that determines the existence of everything. The electromagnetic field governs light and radio waves. The gravitational field keeps planets in their orbits. But in the 20th century, physicists discovered an even more fundamental concept: quantum fields. According to quantum field theory, everything we see around us is the manifestation of invisible vibrations. Particles are only excitations in the field, like waves on the surface of water. The electron, the proton, the photon, they are not tiny spheres, but disturbances, flashes of energy that appear and vanish within the ocean of the field. This idea changed the very picture of reality. One of those who helped the world to see the field as the foundation of being was Paul Dirac, the outstanding English physicist. In his work in the 1930s, he introduced an equation that not only described the behavior of electrons, but also predicted the existence of antiparticles. That became the beginning of a new era. Later, positrons were discovered, confirming that mathematics truly reflects the deepest laws of the world. Today, scientists continue this search. Lisa Randall, professor at Harvard University, has devoted her career to the study of string theory and hidden dimensions. In her books, one finds the bold idea that perhaps our universe is not the only one, and that we live upon a kind of membrane, while alongside us exist other worlds that are almost impossible to perceive. She explains that field physics allows us to imagine space as a multi-layered cake, where we see only one layer, but there may be many more. These ideas find reflection even in culture. In Interstellar, Christopher Nolan relied on the advice of theoretical physicist Kip Thorne to show a world where space and time are warped, and where beyond the horizon of a black hole, something greater may be hidden. Thorne was responsible for the scientific accuracy of the film, including the visualization of phenomena such as black holes and wormholes, as well as for story decisions based on real physics. For example, He developed mathematical models that allowed for the creation of realistic images of the black hole Gargantua and its accretion disk. Here, scientific theories intertwine with artistic images, and precisely this allows millions of viewers to feel the breath of the cosmos. But how is this connected to the human being? The point is that we too are excitations of a field. Every atom of the body, every thought in the brain is the result of interactions within the invisible fabric of reality. When neurons exchange signals, quantum processes manifest in their work, albeit in a very complex form. It turns out that consciousness is not a superstructure, but part of the overall play of fields. There is a remarkable observation made by the philosopher of science, David Chalmers. He says that consciousness may be a fundamental property of the universe, like space or energy. Perhaps the fields out of which matter is born simultaneously contain the potential for the emergence of subjective experience. This hypothesis is called panpsychism, and it is gaining popularity among some contemporary thinkers. To feel this, one may try a simple exercise. For a few minutes, shift your focus away from thoughts and toward the sheer fact of your presence. Feel your breathing, the sounds around you, the light. This returns you to the sense that consciousness is not merely a product of the brain, but part of a wider fabric. Quantum fields are astonishing also because they obey the law of uncertainty. A particle can arise from nothingness and then vanish, and this process is called quantum fluctuation. It is precisely such fluctuations, according to cosmologists, that may have given birth to the universe in its earliest moments. The vacuum turns out not to be empty, but a seething ocean of potential events. Physicist Lawrence Krauss, in his book A Universe from Nothing, describes the idea that the cosmos may have arisen from precisely such quantum fluctuations. From the standpoint of mathematics, nothing is not absolute. Even within emptiness, bursts of energy are possible that may unfold into an entire world. For ordinary consciousness, this sounds unbelievable, yet this is how science explains the deepest mysteries. Philosophy enters the dialogue again. If the universe could have arisen from a fluctuation, does this mean that it is accidental? Or is there behind it a structure that lies beyond our categories? Plato spoke of the world of numbers, where everything is harmonious and immutable. Perhaps quantum fields are the reflection of such a Platonic world, only expressed in the language of modern science. Here a paradox arises. On the one hand, science shows that the universe may be a random play of probabilities. On the other hand, the mathematical laws themselves appear immutable, as though they exist beyond time and space. And then the question sounds again: what governs reality? Chaos or order? The deeper we plunge into the study of fields, the more we sense that our life is part of something unimaginably vast. Every moment is bound to processes that unfold on the level of the universe. And in this, there is both consolation and awe. To not miss the continuation of this journey into the depths of mystery, subscribe to the channel. And when we turn to the fundamental laws of nature, we realize that the key to these mysteries is hidden not only in quantum fields or numbers, but also in that which determines the very flow of being. As we've already said, one of these laws is entropy. Let us consider an example about consciousness and human life that explains entropy through everyday experience. Consciousness can be imagined as a neat order within the head. Thoughts, memories, habits, and emotions are arranged, forming a coherent picture of the I. In childhood, this order grows gradually. The child learns, remembers, forms a personality. With age, as we encounter the chaos of life, stress, loss, and illness, the inner order is disrupted and entropy grows. Memory and experience function like temporary islands of low entropy. When we recall events, systematize knowledge, create habits, we locally order the chaos of information, holding consciousness in an orderly state. But the body ages, neurons gradually lose efficiency, the structure of the brain changes, and order begins to break down. This is the natural rise of entropy. Even death is part of this dynamic. The body returns to matter, memory and experience dissolve into the cultural and biological field, and the energy invested in life passes into new forms. Entropy here acts as a guide, Out of chaos are born new possibilities, new consciousnesses, new systems. It is difficult not to feel awe when it becomes clear that death and consciousness are linked through the same law. Entropy carries us away, but it is precisely entropy that gives us the ability to see and to remember. In this duality, there is something profoundly human. Thus, entropy does not destroy us in the literal sense, but translates personal experience into a wider current, embedding our existence in the general cosmic process. Consciousness is a temporary order in the ocean of chaos, and life is a way to locally reduce entropy and leave a trace in the stream of information. That is, entropy is not only a physical law, but also a universal metaphor of existence. It inevitably draws every system toward disintegration, but in this lies the hidden harmony of the cosmos. Destruction is a form of exchange. The death of a star creates heavy elements. The death of an organism returns atoms to the cosmic fabric. The death of a personality transmits accumulated experience into the field of culture and memory. As we have already said, consciousness can be seen as an island of low entropy in an ocean of chaos. It gathers scattered signals together, gives form to the random, creates ordered pictures of the world. But this capacity is not eternal. The island gradually dissolves into the ocean. And still a question arises. Does the very fact of observation disappear along with the bodily I? Or is consciousness not a product of the brain, but a fundamental property of the universe, like gravity or energy? Physicists increasingly say that entropy is linked to information. The higher the disorder, the more potential information a system contains. Paradoxically, it is chaos itself that holds within it an infinite number of possible forms. Then death may be seen not as a loss, but as the unveiling of this hidden information, the return of individual experience into a wider flow. If so, then consciousness, entropy, and death turn out not to be different topics, but layers of a single phenomenon. They form a unified cycle, the local ordering of experience, its dissolution into the cosmos, and the birth of new forms. We are accustomed to seeing in death an end, but for the universe, it is only a change of configuration. As in the quantum field, a particle turns into a wave. Thus, death is not the destruction of consciousness, but its transformation. What we call the I is only a temporary form, held together by the fragile balance of low entropy. When this form disintegrates, consciousness does not vanish, but returns to the same ocean from which it arose. Here, entropy is not the enemy of life, but its condition, and death, not the enemy of consciousness, but its continuation in another dimension. When we speak of eternity, we most often imagine an endless stretch of time without beginning or end. But modern physics increasingly shows that time is not a fundamental quantity, but a byproduct of processes linked to the growth of entropy. We feel the flow of time because systems decay, heat dissipates, and order turns into disorder. It is entropy that creates the illusion of the arrow of time. Physicist and philosopher Carlo Rovelli, in his book The Order of Time, writes that past and future are not objective coordinates, but only reflections of how consciousness perceives change. For the universe, all events exist simultaneously, like frames of a film that in our experience follow one after another. But what if reality is not a film strip, but an entire library, where every page exists eternally, regardless of whether we read it or not? This understanding overturns our familiar relation to death. If time is an illusion, then the dying person does not vanish, but remains forever in that slice of reality where he is alive. Just as photons exist in many places at once, so do we exist at different points of being, but consciousness catches only one line. From here arises the hypothesis of quantum immortality, which frightens some and inspires others. In every universe where our body fails, there exists another where it continues to live. These ideas seem paradoxical, but it is precisely in paradox that new knowledge is born. At the intersection of physics and philosophy, we begin to understand that eternity is not the infinite extension of time, but the simultaneity of all states. And if consciousness is tied to the very structure of the universe, then it does not vanish, but only changes form. Perhaps this is why human beings have always been drawn to the search for meaning. We sense that our I is part of something greater than a biological organism. When we realize the illusory nature of time and see death not as an end, but as a transition, life is filled with a different depth. Every moment becomes infinite, for it will never disappear from the fabric of reality. And here it is fitting to pause and ask ourselves the central question. If everything already exists, and if death is only a change of form, and consciousness is part of the cosmos, then what prevents us from living as though we are already eternal? To cherish each instant, to notice the beauty around us, to accept change and to act with an open heart, because life in the present is in itself our true immortality. If you share this feeling, write about it in the comments, subscribe to the channel so as not to lose new reflections, and support the video with a like. For by doing so, you too leave a trace in infinity.